So welcome back to Seen and Solved. Today our guest is Dave Govoni, a senior chemist at Hubbard-Hall. Dave's been working with metal finishing chemistries for years, helping manufacturers fine-tune their cleaning and match finishing processes. He's known for his hands-on approach and problem-solving mindset, someone who's just as comfortable in the lab as he is on the plant floor. Stay with us. We'll be right back.
This is Molly Kellogg, President and CEO of Hubbard-Hall, and this is our podcast, Seen and Solved. In each episode, we will share practical solutions to complex surface finishing problems. Let's listen in to the latest episode.
So, Dave, I appreciate you joining us. We're going to talk about mass finishing today. And so for those who may not be familiar, they may not have that type of process or have had little experience with it, how would you describe mass finishing in simple terms?
For those who are not familiar with mass finishing, it's a technique used in many industries for processing multiple parts simultaneously to achieve I want to call it a reproducible finish. And whether that be deburring, removing burrs off the metal, whether it's smoothing the surface, polishing the surface, that type of thing. And this is done generally in several types of equipment, with or without finishing media.
And so there is chemistry involved. What role does that play? And how is it utilized in the mass finishing process?
In general, what I've always said was the purpose of a vibratory compound or a mass finishing compound is basically to keep the parts and the media, if you're using media, clean during the process. There are instances where we're trying to brighten a part, or we're trying to achieve a certain finish. So there are other components of a cleaner that might be used toward getting to that type of a finish. But again, in general, it's keep the parts clean, keep the media clean, and that's pretty basic.
Well, let's talk about the media selection. There's different types, right? And how does that all go into performance and how you match it to a part or a metal that you're working with?
Well, depending upon the type of metal, again, generally the softer metals, we try to stay away from such things as steel media because it can actually impinge on the metal and give you maybe not such a great finish. Plastic media is used a lot on some of the softer metals. Aluminum can be used on zinc for giving you a finish, very low RMS finish for a pre-plate type of application. The ceramic medias, there's quite a few different ones, depending upon whether you're trying to do deburring or if you're trying to polish the surface. So more abrasive, less abrasive, depending on what application you're trying to do. If you're trying to just remove burrs, they have a general purpose type media. The shape of the media is also important, depending upon the configuration of the part. You want to make sure that your media is not going to get lodged in the part. So that's a consideration as well. And the compound that we select, very often they are geared toward more the part than they are the media. Although I have put together some cleaners that will only really work well with ceramic or plastic media.
Walk us through what equipment is utilized in the types of equipment that's utilized in the mass finishing process, if you could.
The first one that I was obviously familiar with was a vibratory bowl. And they can range in size from, I had a 1 cubic foot bowl in my lab. And I actually worked on an account that had a 100 cubic foot bowl. So they can vary in size quite a bit. That is the conventional type of vibratory finishing that we're familiar with. It's probably the oldest. There's also tub type vibrators. So certain types of parts lend themselves to processing them in a tub versus a bowl. We also have what they call inline machines. And inline machines are geared toward a definitive time for processing that you have. So the parts come in one area and then they go out, and then they're separated from the media. The media goes back through the process again. And probably, the newest type of finishing equipment that's out there is a centrifugal disc finisher, which is a very high-speed version of vibratory finishing. It's really more like watching a tornado, if you will, the way the media spirals into the mass. So it's you can cut cycle times down tremendously using
speed things up, more throughput, more parts with that. What industries are you seeing mass finishing being used most in today's world that you've seen?
I've seen just about all types of industries: automotive, aerospace, jewelry manufacturing, even though we don't do a lot of jewelry manufacturing in the U.S. anymore. It was very big in Rhode Island at one time, in Providence. We see it in the medical field. A lot of medical devices are using this type of finishing. Buckle manufacturing, a lot of these industries have now moved offshore. So there is nowhere near the amount of vibratory finishing that we used to see, 20 to 25 years ago that we see today. But it still has a place. It still has a role.
What are some of the most common problems you see with when people are using their mass finishing vibratory? Is it, the foam, sludge, stains? What is it that you're seeing a lot that occur?
One of the things that I see consistently, and unfortunately I still see it on occasion, is although mass finishing is very much a part of the process of getting, a part from its beginning to a finished part, it's an integral part of that process. However, very often we see this equipment in an area of the plant. It's poorly lit. It's not well ventilated.
It's always over in the corner somewhere.
You have people that are not trained very well, and it's just not a showcase for their process. So that's one of the things that I've always attempted to do, is because all of that leads to, dirty parts coming out. So that now they have to go and they have to clean the parts after vibratory finishing. And normally you should not have to do that. If you're running it properly, you should never have to clean the parts following that process. So the staining, how do we dry the part? Are you spin drying? Are you heat drying? Are you cob drying? All of those things go into some of the defects that we see, in the process. And a lot of it, again, is they just don't seem to have people trained properly to look for the right things. Running a bowl half full, for example. Whether you want one part or 100 parts, a vibratory bowl should be at its capacity. So, if you're running one part, I've seen this, you go in there and they're just kind of jumbling around the interior of the bowl. They're not really doing anything, and they wonder why they're not getting the work out of it that they expect. So those are some of the things that I see.
Let's talk about water quality, because I know that's got to be, it's got to be good. I don't know if it's DI water, but what about the water quality and especially how it works with the chemistry and getting very good performance?
Well, anytime that I was working on a mass finishing product, the water quality definitely is a consideration. However, what I found is in most cases in mass finishing, people are using tap water or well water for their process, and as long as you have a chemistry that can handle that, we add components that can handle the hard water salts, calcium, magnesium. If you're dealing with a product that has soap in it, we have to adjust for that in the event that it's being used with tap water that contains high levels of calcium, magnesium. So again, most operations that I have seen are using just straight tap water, and the chemistry generally, as a rule, can overcome any issues that those might create.
I was talking about optimizing performance. And so how can optimizing, say, the compound concentration or the cycle times, how can that help really improve the process, limit rework, those type of things?
The first thing that I generally look at when I look at a vibratory finishing application is I look at the flow rate. Is it the proper flow rate? Concentration, are they running at the right concentration? Are the drains plugged up? Is it draining correctly, properly, adequately? Is the media glazed? Is the media dirty? Is the bowl liner? I always look at the liner of the bowl just above the media line. And if you see, a lot of residue there, you know that it's running dirty. So those are the things that I would generally look at. And it doesn't mean that you have the wrong concentration. You may have just the wrong cleaner, the wrong product. And so those are some of the things that I look for when I'm looking at an account and their finishing application to see where we can do some improving. And, there are rules that I have always followed that I learned early on. For example, in vibratory finishing, the rule that I've always used is you run 8 to 10 gallons per hour per cubic foot. I'm sorry, that's for centrifugal disc. In a vibratory finishing, we run anywhere between 1 and 2 gallons per hour per cubic foot of capacity. So those are the things that I look at right off the bat. We check the concentration. Do they have an LMI type pump that is just dosing? How do I know that I've got the right concentration? Well, I've had to calibrate many of those types of pumps just to come up with those numbers. So those are the parameters that I look for any kind of a mass finishing application.
Let me ask you, what exactly is taking place in the mass finishing machine here? What's happening to the part? In the deburring, like I said, we talk about burnishing, descaling. What's actually happening to the part with the media and the chemistry that are all in there together?
Well, in the case of, let's say, deburring, you're using generally a media that's got enough abrasive that as it wears on the part, it can wear down the high spots. So, a burr generally is a high spot. So it's going to go after those burrs and it's going to wear it down. And again, the compound part of it is to keep all of the material from the media, the wear from the media, any chips, any burrs that fall off of parts, keep all of that flowing, keep it moving so it's not re-impacted onto the part. When it comes to doing a burnishing application, depending on the type of media, if you're using a steel finishing or stainless steel finishing media.
Let's talk about you, because you mentioned the compounds. I was going to say, how do the acidic and the alkaline compound, how do they behave differently in mass finishing and the whole process of that? How do they behave differently in that?
I've always tried to stay moderately alkaline. I very rarely would use a high alkaline product in a vibe finishing because there's some compatibility issues with the lining of the machine. So I've always kind of stayed away from that. In the case of an acidic product, generally with stainless steel media or with even carbon steel media, I've used acids very successfully for burnishing applications. With the ceramic medias, if you're using, for example, a porcelain media, again, I can use some of the acidic cleaners that we've developed. And again, I try not to go too alkaline. We might even go with a neutral product.
Yeah, and again, just like plating baths or things, they use there's additives that can be put in for lubricity and inhibitors and things like that. Talk about those for a bit, and what makes which of those is the biggest difference in finish quality, I guess, when you're looking at it.
I would say probably some of the components that we reach for that would impact on finish are something that would give you lubricity. So if I'm trying to create a burnishing compound for a ceramic media application, I might reach for some kind of a soap, or I may reach for a surfactant that has lubricant properties. So I think those probably make the most impact in my experience with a finishing product.
I think spoke earlier about foam control and such. How do you control that? And also, I guess, sludge that accumulates, especially in a high volume process. How do you control all those?
Well, going back to a previous story that I told about, the impact of a product on the use of polyester resin media in a centrifugal disc finisher. Specific components in the product, for some reason, do not allow development of that foam. Also, when we're creating the product, I also try to make sure that the foaming level is not going to be a problem. The type of media that's being used has an impact, but the size of the media probably is more important. Because as the media gets tighter and packs more, you can tend to keep a lot more foam in the machine. So that's something that we have to consider when we're putting together the product. That even though it works with a normal garden variety sized media, it may not work as well with something much smaller. So that's another aspect that you have to be aware of.
When we talk about regulated, those industries very heavily regulated, such as aerospace, medical, and we talk about medical parts. What additional validation steps are needed when qualifying a compound to use in the process? Because it seems like those would be really spec'd out a lot with those.
I have to say, I don't have a lot of experience in the aerospace part of it. I do know from talking with colleagues that the testing that they have to do is quite rigorous. It's all about impact on the metal, and so I know that it's very expensive testing, but I don't know enough about it to really speak on it. With regard to the medical device industry, I've done some work in the medical device industry, and I know that there's very rigorous testing that they need to do. In fact, we were working on one recently that just finally came to fruition after about a year of testing. They have to do endotoxicity testing and all of a whole array of different tests that I think are probably overseen by the FDA. And even EPA for that matter.
A lot of agencies involved in that, I'm sure, with that. Yeah, when you get deep into it. Last question I wanted to ask you is I always like to, ask, kind of a field story that you had. So I wonder if I could ask you about a problem maybe that you helped a customer solve who was having, struggling with a mass finishing process. You kind of came in, you helped solve it. What was the problem, and how did you go and work to solve that for them?
This was a process that we worked on with the U.S. Mint, actually. When they first came out with the gold dollar, we worked on a product to help remove the oxide that came out of the anneal furnace. So these blanks had a very heavy oxide, and we had to come up with a product that in a mass finishing environment was able to remove the scale before the scale actually got burnished. So they were putting parts into steel media finishing equipment. And in very short order, the steel media can actually start to burnish that oxide. And once you burnish the oxide, it's almost impossible to get it off. So we had to come up with a very quick or a chemistry that could very quickly remove that oxide before it had a chance to burnish. So that's something that I worked on a number of years ago, and it's still being used today.
How many years was that? You say back when the gold coin? I'm trying to think of when we minted gold coins back then. I guess it was the gold dollar, I guess, right?
I want to say it's got to be close to 15 years ago.
Yeah. Okay. Not too far ago then. Interesting. Cool. Well, there you go. You helped the U.S. Mint. Put that on your resume. I think that'd be great. But Dave, listen, I appreciate it. Great information about mass finishing. Sometimes a topic we don't talk about enough, but it's so vitally important. But very much appreciate you taking time out and joining us today.
Thank you, Tim.
Thank you for joining us. Our goal at Hubbard-Hall is to help you get better results with less chemistry. To hear more stories from the field, go to hubbardhall.com or wherever you stream your podcasts.